about a metal M which is belong to the S block of the periodic table and its compounds and the reactions. For these types of questions, it is easy for you to get the answer using a flowchart. Metal M belongs to the S block of the periodic table. It burns with a yellow flame in the presence of excess oxygen gas to give a solid M1. On treatment with cold water, M1 gives a clear basic solution M2 and a covalent compound M3. When S block metals are reacted with oxygen gas or burned with oxygen gas, they produce the respective metal oxide. But when these metals reacted or burned with excess O2 gas, these products varies. With excess oxygen, lithium converts to lithium oxide as previous. But sodium gives the peroxide as the main product. Potassium, rubidium and cesium gives the metal superoxide as the main product. With excess oxygen, group 2 metals gives the metal oxide as the main product. Only barium gives the barium peroxide. Therefore, solid M1 is a metal oxide, or it can be a metal peroxide or metal superoxide. With cold water, these metal oxides converts to the respective metal hydroxides. These metal peroxides, they produce the respective metal hydroxides and hydrogen peroxide. These metal superoxides, with cold water, they produce the respective metal hydroxide, hydrogen peroxide and oxygen gas. These metal hydroxides are basic in nature. Now we will move to the question. This solid metal M1 with cold water gives M2, which is a clear basic solution. Therefore, this M2 is a metal hydroxide and M3 is a covalent compound. According to these two products, this M1 is a metal peroxide because metal peroxide is the only compound which gives this basic hydroxide or this basic solution and this covalent compound, that is hydrogen peroxide. Now we can identify this metal M. In S block, sodium as well as barium forms the metal peroxide in the presence of excess oxygen. This metal M burns with yellow flame. Therefore, we can identify the metal. Metal M is sodium. Then, this metal peroxide, that is sodium peroxide. Next, M2, the metal hydroxide, that is sodium hydroxide. Then the covalent compound M3 is hydrogen peroxide. Now we will consider the balanced chemical reactions involved. During the first reaction, sodium reacts with excess oxygen gas and produces sodium peroxide. During the second reaction, sodium peroxide reacts with cold water and produces sodium hydroxide and hydrogen peroxide. M3 reacts with acidified silver oxide to give a colorless diatomic gas M4. M3 is hydrogen peroxide. Hydrogen peroxide reacts with silver oxide and produces silver, oxygen gas and H2O. Therefore, M4 is oxygen gas. Excess M2 reacts with metal T to give a colorless diatomic gas M5 and a water-soluble compound M6. Addition of dilute HCl dropwise to an aqueous solution of M6 gives a white gelatinous precipitate M7. M7 dissolves in excess acid, but it does not dissolve in dilute ammonium hydroxide. Usually, metals react with acids and produce the respective salt and hydrogen gas. But amphoteric metals react with bases. The most well-known amphoteric metal is aluminium. Therefore, we can suspect this metal T is aluminium. Now we will consider the reactions involved. When aluminium reacts with excess sodium hydroxide, it produces this aqueous complex and hydrogen gas. Now we will consider M6. M6 is a water-soluble compound. Therefore, students, according to this question, we need to consider the anhydrous equation. It's the same equation. We can write the product as sodium aluminate. Sodium aluminate is the anhydrous version of this aqueous complex. Therefore, M6 is sodium aluminate. However, you need to remember the species actually produced in this solution is likely to contain this aqueous complex. When dilute HCl is added dropwise, sodium aluminate reacts with HCl and produce aqueous sodium chloride, aqueous aluminium chloride and water. You can write the same equation for this aqueous complex as well. Then you can see the products are also the same. This dilute HCl is added dropwise. Therefore, the solution is still basic. That means hydroxide ions are present in the solution. Now you can see with dilute HCl, the sodium aluminate, it converts to the soluble aluminium 3 plus ions. Therefore, with the addition of dilute HCl, aluminium forms aluminium hydroxide. Therefore, M7 is aluminium hydroxide. When excess dilute acid was added to aluminium hydroxide, they react together and produce the respective aqueous salt and water. Therefore, we can say aluminium hydroxide dissolves in excess acid. But aluminium hydroxide does not dissolve in dilute ammonium hydroxide because aluminium does not form ammonia complex. If you add excess sodium hydroxide to this aluminium hydroxide precipitate, it dissolves and produces this aqueous complex. And therefore, aluminium hydroxide dissolves in excess sodium hydroxide as well. This is for your additional information. This is the answer for the question number 1. Question number 2. Predict the products of the reaction of M1 with hot water. M1 is sodium peroxide. When sodium peroxide reacted with cold water, the products are sodium hydroxide and hydrogen peroxide. Hydrogen peroxide undergoes thermal decomposition when heated and produces water and oxygen gas. Therefore, when sodium hydroxide reacted with hot water, the remaining products are sodium hydroxide, water and oxygen gas. The answer is sodium hydroxide and oxygen gas. You can write water, but it's an optional because the medium is aqueous. But definitely you have to write sodium hydroxide and oxygen. This is the answer for the question number 2.